Hey everyone, so today we are going to see that if you have a function whose Laplace is f of s, then question is what can you say about Laplace of at, where a is any number. Okay, so I came across this problem in the exercise set of Krzyk textbook, so thought of sharing the solution with you. So we are going to see that the answer is it is 1 by a into f of s by a. So if you know the Laplace of a function f of t, then you can always tell what is Laplace of f of at. For example, suppose if you know that suppose that f of t is e raised to t, and suppose you do the integration and the answer will come out to be 1 upon s minus 1. And now if I ask you what is Laplace of e raised to at, what you do is you simply do this thing. It is 1 by a into f of s by a. So wherever you have s, you replace your s by a. So 1 upon s by a minus 1. You do the cross multiplication and then this a and this a will get cancelled. You have 1 upon s minus a. Okay. Similarly, suppose instead of e raised to t, suppose someone tells you that Laplace of cos t is nothing but s upon s square plus 1. If somebody gives you this and someone asks you what is Laplace of cos at, what is the answer? It is 1 by a, and wherever you have s, you replace your s by a. You do this s square upon a square, so s square plus a square upon a square, and this a square and this a square will get cancelled. You can do the calculation. Answer will be s upon s square plus a square. Okay, so that's how, if you know a function of a function, so that's how if you know Laplace of a function, say f of t, then you can easily find the Laplace of f of at using this formula. Okay, so it's a very nice formula. Now let us try to prove this. Okay, so what is given to you? This is given to you. Okay, so let me erase this as well. So your f of t, Laplace of f of t is integration 0 to infinity e raised to minus s t into f of t dt. And what is this? This is my f of s. Okay, so this is what is given to me. From here, what will be f of s by a? It is nothing but 0 to infinity e raised to minus s by a t f of t dt. Okay, so f of s by a will be this. You replace your s by a. So I am going to use this factor. Okay, now what I want to find? I want to find Laplace of f of at. So by definition, this is 0 to infinity e raised to minus st f of at dt. Now instead of at, you want only one variable. So the obvious thing is you will substitute u equal to at. This will imply that your du is a dt. Now these are the limits for t. So when your t is 0, from here you can see that your u is also 0. When your t is infinity, your u is also infinity. So limits are same. E raised to minus s. What is my t? It is u by a into f of u. And what is dt? It is du upon a. Right? So I hope the calculations are clear. And now from here I think you will get the answer. So Laplace of f of at, so let me write f of as, which is nothing but integral 0 to infinity e raised to minus s by a into u into f of u du, and you take out 1 by a outside. And now if you see, if I replace again u by t, so t will be 0 to infinity, here it is t, here it is t, your du is dt, if you call u equal to t. So this quantity is same as this quantity. So what do you get? This is equal to 1 by a f of s by